Coming to you live from Oakland, California, this is Tim Erickson with something on the Newton-Raphson method. Suppose we were trying to solve the equation cosine of x equals x. We could plot the two functions, see there's y equals x and y equals cosine x, and we would be looking for the intersection of those two curves, which is right there. You can see it's at about 0.75. But this method requires us to find zeros of a function. So we're going to put the x on the other side and say f of x is cosine x minus x. And you can see this function now in green, and you can see that the zero of the function is at the same x-coordinate where the intersection of the two functions was. That is, we're going to be looking for that place right there. Now we're going to make a first guess called x0 at 0.5. It's a terrible first guess, but it'll be illustrative because we'll get to the right answer really quickly. What do we do next? We find the point on the curve corresponding to that x0, and we're going to fit a tangent line to the curve right there. Now, so if this point is x0, y0, we need to figure out what's the coordinate of, what's the equation for the tangent line, as we are going to be trying to find this intercept down here. This is going to be our next guess, is where the tangent line intersects the x-axis. And you can already see that that's much closer to the true answer, where the zero of the green function is, than our initial guess. So what's the equation for the line? We could use point slope form and say y minus y0 is the slope f prime of x0 times x minus x0. You can see this is practically the definition of slope if we put this x minus x0 on the other side. We could also rewrite it. Instead of saying y0, we could say f of x0, put that on the other side. So we have f of x0 plus f prime of x0 times x minus x0. So we're going to find that value there. How will we do it? Well, one way is we could just look at this purple triangle and sort of use slope and our reasoning in order to get it, and that's a perfectly good way. But we can also use this equation setting y equal to 0. And so here we've done the whole thing. 0 is all this stuff, because this is the line where y equals 0. Where is the y equals 0? We're going to take this and solve for x. And I grunge through all of the algebra here, and we finally get down. You can stop the video if you want and see if I did it right. I think I did. You finally get x is x0 minus f of x0 divided by f prime of x0. And this form right here is exactly what we're going to be using throughout this video. And this new value of x, that's x1. So let's find out more about x1. First of all, we can plug in some values and see that it's about 0.755, which looks about right based on this picture. But we really need to zoom in order to see more. So here we go. Here we've zoomed in. Once again, green is the function. That's f of x is cosine of x minus x. And black is the straight line, and its 0, its root, 0.755. That's x1. What do we do next? Well, we do exactly the same thing. We find the value of the function here at x1, which is minus 0.027, and we're going to fit a tangent line here. But when we do that, this tangent line is going to look completely coincident with the green function at the resolution of this screen. So I'm not going to plot the tangent line, but that's exactly what we're going to do. And the next thing that happens is we're going to try to find the place where the tangent line intersects. That's going to be our next guess, which is going to be x2. We can do that by reasoning with the purple triangle, or we can say x2 is x1 minus f of x1 divided by f prime of x1. And we'll get a value of about 0.73914 when we plug in the values for cos x minus x and its derivative at x1, which is here. Okay. And we get 0.73914, which looks plausible based on the axis. So what do we do next? We zoom in again. And there is 0.73914. Once again, green is the function. This time red is the tangent line. And since we've zoomed in so far, we can actually see they're no longer exactly coincident. And once again, we find the value of f at x2, 0.000095. We're going to fit a tangent line in order to find x3 over here. We could look at the triangle, but we can also just use this formula. And pretty soon we realize we're using the same formula over and over again, just with slightly different numbers. We can generalize the formula and say the nth estimate of x is equal to xn minus 1 divided by the ratio of the function to its derivative at point x minus 1, or n minus 1, pardon me. So this is the fundamental Newton-Raphson formula that we're learning here. Let's see what this looks like in Fathom. If I want to do this same thing, here's the value for x2 and f of x2. I've implemented this in Fathom with 5 cases. You can see x2, so here we go. This column n is the number of iterations, so if n equals 2, x2 is 7.739142. Yeah, that matches this. F of x2, 0.4095, look, minus 9.46 times 10 to the minus 5th, that's minus 0.4095. We're doing something right. This n, the formula for n, is case index minus 1 because I wanted to start with 0. We're going to come back to the formula for x. The formula for f is just the formula for the function, cosine of x minus x. So whatever I have for x, it's going to compute that in this column. The formula for f prime, I had to actually take the derivative. I had to know some calculus, and the derivative of this is minus sine of x minus 1. And so this is the slope of this function f at x equals 0.5. At 0.755, the slope is minus 1.68, and so forth. Let's now look at the function for x, the formula for x. I'll expand things out. And you can see if n is equal to 0, I get x0. That's a slider, my initial guess. But if it's not, I get this expression. And this expression is actually the same as the expression in the green box. The nth value of x is the previous value of x, xn minus 1, minus the ratio of the previous function to the previous derivative, prev of f divided by prev of f prime. So we've implemented the recursive Newton-Raphson formula in Fathom using prev. That's how we get the n minus 1 thing to work. Okay? Got that? Good luck.